Hi everyone, my name is Leila Radman bin Sayad. I'm 15 years old in grade 10 at Dubai National School Al Tawar branch. Today I'll be explaining a lesson in physics, which is mechanical energy. In this lesson, we'll be talking about three things. 1. What is mechanical energy? 2. What makes up mechanical energy? And at the end, we'll be practicing. So let's start by asking a general question. What is mechanical energy? You can pause the video to think. Well, the definition of mechanical energy is the energy that is possessed by an object due to its motion or due to its position or both. Mechanical energy can be kinetic energy, which is energy of motion, or potential energy, stored energy of position or due to position, or both. Also, it is the sum of kinetic energy and potential energy. So we can calculate it using this formula. ME, which is mechanical energy, equals KE, which is kinetic energy, plus PE, which is potential energy. The SI unit of mechanical energy is joules, represented by capital J. The last information about mechanical energy is that mechanical energy is conserved when friction is neglected or doesn't exist. And the conservation of mechanical energy means that initial ME equals final ME. Now, let's move on to what makes up mechanical energy. We learned from the definition of mechanical energy that it is the sum of kinetic energy and potential energy. So let's get to know what are these two energies. Let's start with kinetic energy. Kinetic energy is a form of energy that an object or a particle has by reason of its motion or due to its motion. Kinetic energy depends on two things. The first is mass, represented by m, and the second is velocity, represented by v. You can calculate kinetic energy using this formula. Ke, which is kinetic energy, equals half times m, which is mass, times v squared, which is velocity squared. Kinetic energy is directly proportional to m, mass, and v squared, which is velocity squared. Kinetic energy SI unit is joules, represented by capital J. Now here are some examples of kinetic energy. A moving car has an amount of kinetic energy. This is because it has some mass and velocity. A bullet fired from a gun has kinetic energy. This is because of a large amount of velocity possessed by the bullet. Although the mass of the bullet is less, its high speed doubles the amount of kinetic energy. Now, let's move on to potential energy. Potential energy is the energy due to the position of the object, and it is stored energy. The main type of potential energy is gravitational potential energy. Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. Gravitational potential energy depends on the height and mass of the object. We can find it using this formula. GPE, which is gravitational potential energy, equals m, which is mass, times g, which is gravitational acceleration, and on Earth it is constant. It is 9.81 times h, which is height. The SI unit is joules, represented by capital J. Now here are some examples of potential energy. A raised weight, a yo-yo before it is released, a child at the top of a slide. Now let's practice by trying to solve a question. The question says, a boy that is 0.9 kilograms is sliding on a slide with a velocity of 0.5 meters per second at a height of 2.3 meters. Find the kinetic energy, potential, and mechanical of the boy. So let's start by stating the given. We have mass, which is 0.9 kilograms. We have velocity, which is 0.5 meters per second. And we have height, which is 2.3 meters. So let's start by finding the kinetic energy. First of all, we state the kinetic energy equation, which is Ke equals half times m times v squared. We replace the m and v, and we'll end up with kinetic energy equals 0.1125 joules. Then let us find the potential energy. As we did in the kinetic energy, we need to state the potential energy equation, which is PE equals m mass times g, which is gravitational acceleration, times h. As you said, g is constant on Earth. It is 9.81. We replace m, g, and h, and we'll end up with potential energy equals 20.3067 joules. At the end, we need to find mechanical energy. We learned previously that mechanical energy is the sum of kinetic energy and potential energy. So we add these two energies. We add 0.1125 plus 20.3067. We'll end up with 20.4192 joules, which is our mechanical energy. Thank you for listening.